in this example, we're going to use the general multiplication rule to find probabilities of dependent events. So you've got some music on a digital music player, 6 tracks altogether, and you decide that you like 2 of the 6 songs. You place it on a random feature, which what it does with the random feature is it plays each of the 6 songs once in a random order. Now, because it plays those songs only once in the random order, that makes this a dependent probability situation. So think of it like this. If the first song that's played is the song you like, then the second song that's played can't be that same song. or even if it's one that you didn't like, it's just not going to be the same song. So those are not repeated, or it's not replaced into the set of songs that's going to play on the recorder. Okay, so with that said, let's find these different probabilities. So part A asks the probability that you like both of the first 2 songs. Okay. So that would be the probability that you like the first one times the probability that you like the second one, given that you like the first one. So the probability that we like the first song would be 2 out of 6. There's 2 songs that we like. There's 6 total songs. That one's pretty simple. The second probability, we just have to take a second to think about it. We've already picked, or we've already listened to that first song. We liked it. So there's only 1 song left that we like. Also, we've already listened to a song, period. So that means there's only 5 songs left. So this is now our probability. And that would be the following written as a fraction. And of course, if my math lab asks you to express that as a decimal, just do that and watch for rounding. Now, because this one's asking us this additional question, is that unusual? I will express that as a decimal 0.067 approximately. And using the 0.05 as a mark for unusualness as far as probabilities go, this one's greater than 0.05. So we would say no, this one is not unusual because this probability is greater than 0.05. All right, so for the next one, let's find the probability that you like neither of the first 2 songs. So that's the probability that you dislike the first times the probability that you dislike the second, given that you dislike the first. So the first one should be pretty straightforward. You find the total number of songs that you dislike over the total number of songs altogether on the digital music player, and that's 4 out of 6. The second probability, just take a moment to think about that. Remember, you've already listened to 1 song. And the 1 song that you listened to, you also disliked. So now you only have 5 songs left, 3 of which you dislike, and you're trying to find the probability that you dislike the second song. So that would be this probability. And just multiply that out and express that as a decimal as needed. And for this next part, we're asked to find the probability that you like exactly 1 song. So there's a couple of ways that could happen. You could find the probability that you like the first times the probability that you dislike the second song, given that you like the first. That's one possible scenario. So let's go through that first. So the probability that you like the first song is 2 out of 6. Remember, you've already selected one song. It's gone. You have 5 songs left. So of those 5 songs, you now dislike 4 of them. So that means that would be 4 over 15 is the probability that it happens in this order. But then there's a situation that that order is reversed. So what if we dislike the first song and we like the second song? Of course, given, remember that we dislike the first because it's already played. Okay, so that one would be the following. Let's see. So that we disliked the first. There were 4 songs we disliked out of 6. Remember, you've picked one, so now you have 5 songs left, of which you like 2 of them that are left. Notice that we have the same thing here. And this is one possible way the outcome can occur. This is the other way it could occur, and that's joined by the statement or. So it could be this scenario or this scenario, and in that case, mathematically, we add those values together. So we're adding together 4/15 plus 4/15, and that should give us 8/15. Another way we could have thought of that is multiplying it by 2, taking the first and multiplying it by 2. Now, in the last part of this problem, we're asked to redo all 3 parts, assuming that any of the songs could be replayed. In other words, we're taking away that dependent condition, and now we have probabilities of independent events. And so I'm going to show you this with the first part, just for the sake of time. It looks like this now. So part A would now read like this. The probability that we like the first song times the probability that we like the second song. And the probability that we like the second song is the same as the probability that we like the first, because these things could now be repeated. So things change here as well. Let me erase all this information here. There are 2 songs out of the 6 that we like. So that would be 4 out of 36, or 1/9. And you would do something similar for the remaining parts.